Howdy folks, John here from rchelicopterfun.com. Today we're going to be doing a full setup of the Flywing H1 GPS Autopilot system. I did a review on this little unit a couple of weeks back and been getting enough positive feedback from you guys that you wanted to see a full setup tutorial, so here we are today. Hopefully by the end of the video you'll have a much better appreciation of the configuration and setup steps. Over and above the H1 unit itself, you're of course going to need a helicopter to install it into. As I mentioned in the review, I chose this ALZ Devo 505 I had for several reasons. Primary one being the mounting location. The H1 is very specific to mounting orientation. It has to be mounted upright, has to be pointed forward in the direction of flight, has to be level of course, like any flybarless system. And in this position, the servo outlets are at the rear here. Now, the Icon 2 FBL unit I had in here before was the exact same, so I didn't have to dick around with servo lead length or anything. The plugs were already back here, a plug-and-play installation essentially. Also with this helicopter, we've got good spatial separation between the motor and the unit itself. These have got a magnetometer in them for the heading positioning. And the further away you can get it from any strong magnetic fields, the better. Powering requirements. The H1 is quite specific. It needs 6.4 to 8.5 volts. This specific helicopter, I've got a programmable BEC in it. I've got it programmed to 7.4 volts output, and I'm also running HV high voltage servos. So the voltage requirements are in spec. And last up is the position of the GPS pod. They want it mounted out on the boom, wire of course facing forward in the direction of flight. You have to take into consideration the mounting location of it in relation to the unit, so you've got enough wiring length. And this little heli checked off all those boxes quite nicely. You're also going to need your radio or transmitter. You're going to need a Windows PC or laptop to download the software, the setup software. You're going to need internet connectivity. If by chance you've got my Swashplate setup and leveling ebook, you might want to dig that out because a lot of the steps we're going to go through are covered in much greater detail in here, so it might help you follow along. And last up are the tools you're going to need, just your basic Swashplate setup tools. You need a swash leveler, whatever you use for leveling your swash plates. You're going to need a pitch gauge to set and confirm your collective ranges. You may need ball link pliers to pop off the push rods to mechanically level your swash plate after you electronically level your servo arms. I've got the rotor head removed so we can see the swash plate leveling process a little bit easier, but I also needed it removed for this specific type of leveler. Any tools you might need to remove the head if you have to. And I have a digital caliper. I like measuring my push rod lengths, but you may or may not find that useful. So let's go on to Flywing's site and I'll just show you really quickly what you have to download. I'll fire a link below in the description to Flywing's website. Once on it, go into the flight control system and click on software. And there's a couple of things you have to download off of here. First is the actual setup software. It's this H1 Heli EN Beta, and it comes in a zip file. And you're also going to want to download the PDF of the H1 flight controller manual. So once you get those downloaded, as I said, it comes in a zip file. It will have the driver and the H1 Heli application. The driver auto installs, and Windows will say it doesn't recognize it, but just ignore it. And once you get those installed, you'll have the manual, and you'll have the setup wizard, setup assistant, whatever you want to call it. And now we have to plug the helicopter in. So with the software and driver installed, we can plug the unit into the computer through the included USB cable. It's a USB-C, so it's nice. It's non-orientation dependent. It'll plug in either way. And we heard the computer do its little tune, meaning the driver software must be working. It's recognizing the unit. You'll also see the unit is being powered through the USB, so you don't have to have it powered up through the aircraft's power system. You can just power it through the USB for the first initial steps of the setup. In fact, for safety reasons, you may not even want to have your ESC or servo plugs plugged in. Just have your receiver plugged in. As it mentions in the instructions, and as I stated in the review, these units accept S-Bus protocol and some PPM protocols, so you can look in the instructions what it is compatible with. I'm running it with an FrSky receiver with S-Bus output, no problem. As far as plug orientation back here, you probably noticed it says also in the instructions, ground is on the top, signals at the bottom, and power is in the middle of the power rail. Oh, speaking of power rail, the servos all share a common power rail, of course. So if you were not feeding it power through your ESC plug, you could put a Y splitter in any one of the servo outputs and feed power in that way as well. So it's up to you how you want to power it. Just keep in mind though of the power requirements, 6.4 to 8.5 volts. I already pre-browned that FrSky receiver to the radio, so I'm just going to turn the radio on right now and make sure the unit is communicating with the receiver.
You turn me on. Throttle hold.
So the LED goes solid, meaning it's recognizing receiver signal. So we're all good there. Here's the main page of the H1 setup wizard or setup assistant, whatever you want to call it. We're going to connect it to the unit. It may give you several COM port options. I know on this computer the USB plug is plugged into COM port 6. So I'm going to change that to COM 6. We'll hit the connect button. This can sometimes take a while to connect. And once connected, you get this green circle. If you stir your radio sticks, everything should move. So we know it's communicating okay with the software. So we're going to go into install new helicopter. So we're setting up a brand new heli here. As I mentioned in the review, one of the big downsides to this setup assistant is there's no way to save any pre-configured helicopters. So if you hit that, you'll erase everything you've done. It's a big limitation to this software. Anyway, it's got several pre-configured helis. This list will no doubt grow as they keep updating the software. Now, if you've got one of these specific helis, you can certainly choose it, but be very careful that you recognize what motor, ESC, and specifically servo combinations are also selected. And what you really want to pay attention to here is your tail servo selection, because this unit supports both regular 1520 microsecond and narrow band 760 microsecond tail servos. It only supports 1520 cyclic servos. But if you were to choose a pre-configured model with a narrow band tail servo and your tail servo wasn't narrow band, there's a good possibility you'll overdrive that servo as soon as you power up the system. As it turns out, our 505 isn't even in here, so we have to resort to the blade sizing method. Now, all this does is it's a shortcut to pre-select a bunch of parameters. It's nothing saying you can't change all these down the line, but obviously best to pick the closest option you've got here in size, and you can select anything between 325 millimeter rotor blades all the way up to 810. So basically, 450 size helicopters up to 800 size helicopters. No 600 in here. It goes from 570 up to 700. So don't know what that's all about. Obviously, you'd probably just pick the 570 if you had a 600 size machine. But there's a 500 size machine running 505 millimeter rotors. So we're going to select this center one. So our first setting that we have to program is our transmitter settings. And this is just ensuring your radio is outputting the channels in the correct direction and ensuring the system knows your minimum and maximum and center points of all your channels that your radio is outputting. Now, before getting to the actual radio outputs, I wanted to talk about channel mapping a little bit. This uses Futaba channel mapping essentially. We'll just go over it real quick. And the reason this is important is you cannot change channel mapping in here. What these are assigned to is the channels they're expecting to see inputs from the receiver. And if your radio doesn't have the ability to swap channels around for different inputs, like OpenTX does, gives you lots of power, but on a pre-configured radio, you may be stuck. Aileron is channel 1, elevator is channel 2, throttle is channel 3, although in this it's being used as your collective. Channel 4 is your tail rotor or rudder output. And then you need to be able to assign toggle switches to the remaining channels. Channel 5 is the GPS
Return to launch.
and return to launch and 3D mode selection switch. Channel 6 is not used at all. Channel 7 is the throttle activation.
Throttle hold. Throttle release.
And your auto flight
Circle mode.
is channel 8. And what's not shown on here because we haven't set it up yet is the invert, which is channel 9. So if you want all functions out of this, you need a 9-channel radio with a receiver that outputs 9 channels minimum. Go into your monitor screen. That's probably the easiest one. It's one of the most useful menus of any computerized radio. I keep telling beginners that, get used to that menu because that tells you everything that's going on. All your programming that you've done in your radio, you can confirm it on this. If you've got dual rates, make sure those are turned off. You want 100% travel in both directions, and sub trim and trim, you want those all centered. So on your gimbals, you want to see all the positions perfectly centered, and you want to see 100% output. So first thing we're going to set here is the directions. I'm just going to do it with the elevator channel, but you would do it with all of them. So when we push the elevator stick forward, of course we want to see the elevator indicator here go forward, but it's going backwards. So we have to go into the radio and change the direction of that channel. I've gone through all my channels to ensure they're moving in the right direction that the setup wizard wants to see them moving. Tail rotor right, tail rotor left. Aileron right, aileron left, collective positive, collective negative. And same with all the mode switches.
Return to launch. GPS mode. Throttle release. Throttle hold. Flight mode 8. Circle mode.
So we know all that's set properly. We're going to start calibrating it. We're just teaching the unit the maximum output of each channel. So you just stir the sticks so it learns the maximum output range. And when you're done doing that, hit OK. And then it's going to show the min and max values for each channel. That all looks good. They're all even at 2006 microseconds for maximum and 982 microseconds for minimum. Click OK to write. Okay, we'll hit next to get into our swash programming. Before doing any of this though, because we have to power up the servos, we have to plug in the battery to power up the system, I just want to make sure we've got the correct tail servo selected. It does give you 2 tail servo selections, either narrowband 760 or regular 1520. This helicopter, I am running a narrow bandwidth tail specific servo, so we have to select the 760 for it. We'll finish the tail setup later when we're done everything else. So we'll go back to swash. There's instructions as well, so you can read them as well. I would recommend it. First thing we're going to do is select the type of ECCPM 120-degree swash layout we've got. We've got 2 options. They're using Futaba's Swashplate identification of either H3 or HR3. On this 505, we're actually using an HR3 configuration where we've got the left and the right servo inputs on the front ears and the elevator or pitch servo on the rear ear. And swash trim, this is the wrong term. We are actually leveling or centering our servo arms here. We're not trimming the swash plate out at all. So first thing we're going to do is make sure all the servos are moving in the right direction. You'll notice you've got these normal and reverses here. You hit this all servos up and you want to see all the servos moving in the correct direction to get the swash plate moving up. And on my swash plate, looks like they all have to be normal. So it's in the start position now. When I hit all servos up, all of them are moving up to move the swash plate up. So if your swash plate, if only one quadrant was moving up and the other 2 quadrants down, you'd have to reverse those 2 servos. in the setup wizard. Now we are going to level or center all the servo arms. I'm just going to do the right servo so you can see it, but of course I've got to do all three. Zooming in on our right Swashplate servo here. As you can see, I've got the arm removed. If you don't know if your servos are centered, never install your arms until after you've powered them up so they can center properly. Now what we want to do first before we electronically center anything is fit the arm on the best spline position that gets us as close to level as possible. So there, in that spline position, sitting way too high, right? So that's not going to work. Let's move it one spline down, see if we get a little bit better here. There we go. So still sitting a little bit high, but a lot better. Now we'll just draw kind of an imaginary line between the servo output shaft and the mounting screws. And we will go into our setup wizard, and using that slider, we will move the servo back and forth until we can eyeball it dead level, which is right about there. Yeah, I'm happy with that. Let's do the other two. So I've got all three of my Swashplate servos centered and level now. I had to go 1527 for the left. Notice they call it the lift. Right had to go 1454, and the rear servo, or the elevator and pitch servo, had to go 1554. So arms are all nice and level. Now we have to mechanically level the Swashplate. Get out your trusty swash leveling tool. Now this isn't the exact one for this helicopter, but it works. And get the 3 ears of the swash tool on the 3 ears of the Swashplate. I have to offset it a little bit because this is a fairly big swash leveling tool. Now what you're going to want to do here, we know all the servo arms are nice and level, and we just have to make sure all these ears are touching the 3 quadrants of the swash, which means the Swashplate is perfectly level in relationship to the main mast. That's why I like these tools so much. You're not dicking around with leveling the helicopter or anything. You are referencing right off the main mast, which is what the rotor head is referencing off of. So as long as your Swashplate's level, your rotor disc is going to be level, your heli's going to be in trim off the bench. So you can't see the back one, but it's sitting on the swash tool ear. The right one's sitting on the swash tool ear, but if we zoom in on the right one, you can see there's just a little gap there. So this Swashplate is angled slightly down to the left. So to cure that, we're gonna have to pop this ball link off for this push rod, and we're gonna have to raise the push rod. So we'll go one turn here. Pop it back on. Let's see where we're sitting now. No more gap. So all the ears now are sitting against the swash tool. So our Swashplate is perfectly level in relationship to the main mast. Swash leveling and setup is done. On to collective. Before getting into the actual settings of the collective, very important that we don't use any pitch curves. This H1 unit does all the collective management for us. So we just want a linear output for the pitch channel, channel 3, and you also don't use throttle curves with this. Again, follow the instructions in the manual. And in this, we are just setting our 0 position and our maximum collective and our minimum collective. And they're saying in here it should be around 12 degrees. For most collective pitch helicopters these days, that's about normal, but double check your manual for your specific helicopter model. Some are recommending plus minus 10 degrees maximum collective range. So if your manual calls for something different, don't use the 12, use what's in the manual. The 505 runs a plus minus 12 degree range, so that's what we're going to be setting here. So got to fit the head back on, and we'll fit a blade and the pitch gauge. Got our rotor head fit back on. For those of you who have got my Swashplate ebook, this will look very familiar. A textbook head geometry setup here. At midpoint on our pitch curve, or in this case, mid-channel travel on channel 3, our servo arms are all perfectly level. Swashplate is perfectly level. Washout arms, perfectly level, and we are producing exactly 0 degrees of collective pitch. And at maximum negative collective, we're producing minus 12. at maximum positive collective plus 12. And we'll confirm that on the pitch gauge. So our pitch gauge is set. We've zeroed it out. The blade is at exactly 0 degrees of pitch. I show in my Swash book how to do that. If you've got hash marks on your blade grips, you can go by that. You can fold the blades together to make sure they're at 0. Whatever method works best for you. We'll go to maximum positive, and we're sitting right around 12 degrees. Go to maximum negative, and again sitting right around minus 12 degrees. So this is set up perfectly. And on the screen here, we'll just zoom in. So I didn't have to change my 0 collective position from 1500 because I took the time to do it mechanically, so we didn't have to worry about that. And I had to tweak this one and this one a little bit to get the 12. So let's say if let's change this one back. We'll go to center here, and we'll go back down to the gauge. So you'll see it's only producing 10 degrees of collective. So that's why we had to dial that one up. Just dial that little hash mark up until you're sitting right around 12, or whatever the min-max range is for your specific helicopter. Ooh, one thing I thought I'd mention, I get this question a lot on my website. A lot of people, they pull their hair out because they're checking both blades. You only need to check one blade. If you've got a set of digital calipers, or even just eyeballing them side by side, if you get your pitch arms, the ones that go up to your blade grips, if you get those exactly the same length, you know your collective pitch angles or both blades are going to be exactly the same. Any minor variance will be corrected during blade tracking. As long as these two push rods are the exact same length, your tracking will probably be almost perfect off the bench too. That's why I like using digital calipers to measure these. I get them almost bang onto each other, and blade tracking is usually perfect off the bench. We're in the home stretch here, folks. We're finished with the collective setup onto the tail. We've already gone over the servo type. Here's where you will center the servo arm on the servo, similar to how we were doing it with the Swashplate. We will set the maximum left and maximum right travel of the pitch slider on the tail rotor, and we will change the direction if needed. So in the setup wizard, we go into the servo trim for the center position, and we can move it either left or right. And we just want to get it so that arm is perfectly vertical, so it's at a right angle to the push rod going down to the pitch slider. I'm not going to get into all the nuances of tail rotor setup because I've got a separate video of it. I'll put a little card link up there in the corner if you wanted to look at that. We're just going over the H1 setup of the tail. So we've centered the servo arm, and when we center the servo arm, depending on your machine, but most will be like this, you want the pitch slider perfectly centered. So there's equal amounts of tail rotor shaft on the left side and the right side. And on most helicopters, that's going to be giving a little bit of pitch to counter the torque. Now, in the setup wizard, first thing we're going to do is see if it's in the right direction, if we have to change that. So we hit the left button in the tail setup screen, and you can see this pitch slider has moved right. That's not correct. We wanted to see it move left as per the instructions in the setup wizard. So we're going to hit tail direction. We're going to switch that to reverse. There. So now when we hit the left button, it goes left. When we hit right, it goes right. And when we hit center, it's back to center. Now we just have to set the maximum range to the left and right. So we're going to hit the left button again, and we're going to move that slider. You can move it back and forth to increase the travel range. And we're just going to keep moving it until it bottoms out. There, and when it bottoms out, the servo will start singing. So just back it off a bit so the servo's not singing. And right, we'll do the same thing. We're going to move it more outward to the right until it bottoms out. There, it starts singing. Just move it back a bit until that stops. And there's our left and right ranges set. So the system knows the maximum mechanical travel range of the tail rotor pitch slider. Perfect. Almost finished the setup now, so we'll just go over our tail settings real quick. So we've got our servo set to the right centering position. We had to reverse the direction, so these pitch sliders moved in the right direction when we clicked left and right. And as you can see, we've had to increase our left travel range out to here, and our right travel range out to here. So we're getting the full travel range of the pitch slider on the tail shaft. Now we hit finish. So just a couple more things to set in our main home page of the H1 unit. First is tail gain. Tail gain is set through the unit itself. You can't change it on the fly through a remote channel. I always set my gains on a new machine until I know how it's going to behave, right around 50%. And this is just heading lock mode. This doesn't give you rate mode tail gain at all. So you've just got a heading hold or heading lock tail gain. So we'll set it at 50%. Throttle control, this will be dependent if you run linear throttle outputs on your ESC or if you use governed functions in your ESC. I run linear on this machine. I'm going to set it at about 65% power. That should give us a high enough head speed that we don't get cyclic wobble, but not too fast to make a huge cratering hole in the ground if this thing screws up on us. And this is where you would set your channel 9 if you wanted to use channel 9 for the inverse flight. It can either be off or on, and there's some instructions in here. Just to let you know, if you're turning it on, you're increasing the danger factor. And there's this easy and professional. Easy will invert all your controls as soon as you go inverted. So it doesn't give you the true channel reversals that normally happen when you go inverted. If you pick professional, then you will get those channel reversals. But we'll leave it at easy for now. And now we'll go to main rotor. This just shows those values we set before for the Swashplate and the collective range if you had to trim any of this, but we don't have to. And we'll go to parameters. Now this is where you're going to set what type of flying style you're going to use. I'm going to start with standard flight. And this just pre-selects a bunch of these outputs. I won't get into all of these. I cover all this stuff in great detail in my Swashplate and flybarless configuration ebook. Of course, I don't cover GPS attitude mode because normal flybarless systems don't have it. I'm just going to leave it at the predetermined ones. So we're having about 33% self-stabilization. This just dictates how the unit will self-stabilize the heli. If you go too high, you'll get wobbles. If you don't go high enough, the heli will be very vague in its autopilot correction. Braking force is just how much the helicopter will back up. Like when you're flying forward, of course, you've got momentum, and when you center the stick, this will dictate how fast and how aggressive the helicopter slows and comes back to a hover. If you've got low braking force, it'll keep drifting forward as you center the stick and slowly come back. If you've got higher braking force, it'll be very abrupt. And maximum flight speed, that's pretty self-explanatory. 3 meters per second, that's the maximum flight speed it will fly, and I'm okay with that. Swash gain, as I said in the review, this is a big downfall as far as I'm concerned. They've combined the pitch and the roll gains into one, so you can't separate them, and you normally want to separate them on a helicopter with lots of mass along the pitch axis and not as much mass on the roll axis. Swash exponential depends on your radio. If you run exponential rates in your radio, you can turn that right down. Swash rate, just how quickly the swash moves, leave it set at 50%. Agility, just how agile the helicopter is, leave it at normal. Tail rate, slow. Now I'm going to dial that up. We'll go up to 50 here. This is just how fast it pirouettes. I have no idea what this DMA collective is. Again, this is a downfall of the setup wizard in the manual. It doesn't give you any indication of what these are. Most flybarless systems, as I had said in the review, when you hover over each of these, a little help window would pop up with what it does and tips, but you don't get that with this. So let's hope they improve this setup assistant. I don't have battery protection on, so that's turned off. If you had turned that on, you would have to hook up that other battery lead, which I showed in the review, and tie it into your ESC. Don't hit restore default settings. It will reset everything, not just everything on this page, but all your previous settings as well. Don't hit it. And last up, set the magnetometers, calibrate the magnetometers. We have to go outside to do that. If you've ever calibrated the magnetometers in a GPS-enabled quadcopter, exactly the same thing here. In the setup assistant or setup wizard, you've still got the helicopter plugged into your laptop, just got the laptop on the grass. There's 2 status bars in there, one for the magnetometer for the H1 head unit and one for the GPS unit. And as you rotate the helicopter through its 3 axes of rotation, yaw, both directions, pitch, again, both directions. I'm doing this real quick. Roll, of course, both directions, and do it inverted as well. Start inverted, do the yaw, a full 360 degrees each way, roll 360 degrees each way, and same with pitch, and you'll see those status bars slowly filling up. First test of the H1 GPS autopilot system here. And this is by far the scariest, completely unknown system. Done all the checks, everything checks out fine, calibrated the compasses, all that. Everything seems to be functioning normal, but what's scary about this is I'm in no control of the helicopter. The system is in total control. So if something goes south, yeah, it could get ugly. Thus, there's no canopy on it. If this thing crashes, I want as minimal damage as possible, and I've even fit training gear because we just don't know, right? So let's put it into GPS mode and arm the ESC.
Throttle release.
Well, so far so good. It hasn't taken off or rolled onto its back. So I'm just slowly increasing the collective. Nothing seems to be happening yet. Oh, there we go. It's a very calm day too. I wanted to make sure there wasn't much wind, but that is absolutely hands off. Go in for a cup of coffee now, right? Wait for the battery to die out. I don't trust it quite that much yet.
Rudder medium. Rudder low.
So you can use dual rate still, but you can't have dual rates on
Rudder high.
to arm the ESC. You need full rates. It's not what I would call a great feeling helicopter, but it's very robotic. Of course, there's going to be tuning involved. But pretty decent. At this point, I know the system works. Seems to recover fairly well. Little bouncy, little feedback there. But it's going to take tuning. But at least we know now that the system is installed correctly and it's working correctly. And we can go out to the field and start making sure all the other stuff is working on it. You know, the return to home, and see if we can get it inverted and see if it's got hands-off inverted flight as well. One thing I noticed though, the collective is not responsive at all. It's very sluggish. So you don't get a really good collective feel, but you know, that's to be expected with any autopilot system. They're all like that. So those are the basic setup and configuration steps of the H1 Autopilot system. If you've set up any flybarless systems before, lots of similarities, right? So hopefully it helped you out. Cheers, folks. Thanks for watching, and we'll see you next time.